Today, I'll start by motivating why evaluation matters and how we've been thinking about LLM as a judge, both the strategies people use and challenges that show up. I'll cover some existing human-centered tools and why we built our own MVP, which eventually evolved into EvalAssist. And from there, I'll walk through the design goals behind the system, give an overview of the platform, and then share our findings on our study. So let's start with some motivating examples that we see in our day-to-day at IBM. So this is a situation that some of you might be familiar with, but let's say you are an engineer or a practitioner building a customer support chatbot in an enterprise setting. You've done everything right. You have reference documents, you have a RAG pipeline, and now you're experimenting with different models. You take one simple customer question, something like, can I add my partner to my insurance? And you run it across different prompts, different models, and different settings. And suddenly you don't have one answer, you have dozens. Some are short, some are detailed, some are confident but wrong, some are technically correct but incomplete. How do you know which one to choose? Which response is the best one? So when it comes to evaluation, teams usually consider three options. The first is manual evaluations. This is humans applying rubrics. It's high quality, but slow, expensive, and impossible to scale. The second is automated metrics like Blue or Rouge, and these rely on n-gram overlap with a reference document, but this only works if you have reference documents. In many real-world settings, like open-ended generation and customer support safety, you don't have reference documents. The third approach is LLM-as-a-judge, and that's when an LLM judges outputs, and I'm going to cover some strategies and challenges. So LLM-as-a-judge is attractive because it's flexible, it's scalable, and works even when there's no single correct answer. And there's two dominant ways this is done. So there's direct assessment, where you design a rubric and ask the LLM to score or explain an output. And then there's pairwise comparison, where you simply ask which is better, A or B. LLM-as-judges are good solutions in a lot of cases, but they're not without their faults. So there's a bunch of biases that they exhibit. There's positional bias. This is the order that you present outputs can influence which one the model prefers. There's something called self-enhancement bias, and this is when the judges favor answers that look something like they themselves would have written. So for example, a llama judge might prefer model outputs from a llama model. And then there's verbosity bias. So this is longer answers tend to score higher even when they're not better. So because LLM-as-a-judge is a viable option in a lot of evaluation tasks, there have been a wave of AI-assisted evaluation tools that explore different pieces of the evaluation workflow. These are tools like ChainForge, EvalGen, EvalLM, LLM Comparator, and they all adopt a human-in-the-loop model where people interact with the model outputs, provide feedback, and iterate. And across a lot of these systems, the evaluation process is not static. Criteria and expectations evolve as users see new outputs. So a lot of these tools make a few assumptions that make them inappropriate for some of the contexts we were describing earlier. First, they couple prompting and evaluation, whereas in the practitioner reality, especially in retrieval augmented generation cases, the prompting and the workflow are happening elsewhere. Second, they scale first, whereas the data sets we were seeing were incredibly large and required iteration on a small subset before applying criteria and evaluation to the entire data set. And so we wanted to keep these things in mind as we were thinking of a solution to some of the motivating examples we described earlier. Next, I'm going to be talking about the evolution of our system, starting with the very first version, which we call EvaluLLM, and then how that evolved into EvalAssist. In our very first version of EvalAssist, which we called EvaluLLM, our goal wasn't to build a final evaluation system. It was to understand how teams were actually evaluating LLM outputs in practice. So from interviews and early use, we saw that teams wanted flexible scoring, the ability to define dimensions, assign negative scores, and express that some criteria mattered more than others. EvaluLLM frames the evaluation as a simple pairwise preference problem. For each example, we run the prompt across multiple models and collect their outputs. Then an evaluator model looks at the outputs two at a time, along with the task context and natural language criteria, and picks which one better satisfies it. The evaluator also gives a short explanation, and once we have all those pairwise choices, we aggregate them into a win rate score, both per example and at the model level. And then users are provided with a leaderboard. So our earliest version of eval-LLM looked like this. In the build stage, users set up an LLM-assisted evaluation by selecting the data set, defining the task prompts, choosing models to generate outputs, and specifying natural language evaluation criteria. And we conducted a user study and recruited 8 domain experts. We had participants interact with the tool and think aloud, and they were doing a standardized task using an LLM-as-a-judge to evaluate model-generated headlines and identify the best output. We then analyzed their feedback, and 3 main themes emerged: use case challenges, evaluation criteria, and evaluation workflow. So for the use case challenges, we found that practitioners often evaluate under uncertainty. Specifications are incomplete, data sets are messy, and evaluation priorities shift over time. Early in the project, they care about correctness, but later they care about quality and style. They also need to compare models with different configurations under tight time and compute constraints, which makes evaluation a moving target rather than a static benchmark. Users also talked about evaluation criteria. So defining criteria turned out to be one of the hardest aspects of the workflow. Users don't have criteria in their heads, they iterate towards them. They start with more objective criteria, such as accuracy, and only after seeing actual outputs do they add more subjective dimensions. And third, evaluation workflow. Practitioners do not evaluate end-to-end in a single pass. They stage it, they start small, they refine criteria, they test alignment between themselves and the judge, and only then scale up. And people talked about how transparency and bias mitigation are crucial for trust. Participants wanted to know how the judge decided, whether the criteria was followed, and when the judge disagreed with themselves or other human annotators. So from these results, we were able to extract design goals for the next version of our tool, EvalAssist. And these are our 7 design goals. I'm going to go through each of them one by one. So our first design goal was to separate generation from evaluation. In practice, ML practitioners already do this. They generate tons of outputs from different models or prompts, and only later do they evaluate them. But current tools force everything in a single loop, focusing on prompting and variations that result in output as a result of those very prompts. So EvalAssist supports workflows by letting people generate at scale and then evaluate using consistent criteria. Our second design goal was to support users to iterate on a small sample first to reduce cost of evaluation. So in practice, users don't want to evaluate hundreds or examples up front. They want to start with a small sample, iterate, tune their criteria, and only then scale. And EvalAssist makes this easy. You can experiment on a small subset, refine what good looks like, and once you're satisfied, export that criteria and apply at scale through our SDK. The third design goal focuses on instant feedback for human-AI agreement. So rather than waiting until the end of an evaluation run, users get real-time signals about whether the model aligns with expected labels. And when it doesn't, the system can provide explanations. Our fourth design goal was to support multiple AI evaluators. So in practice, people don't want to be locked into a single judge. Different judges can have different preferences and different biases, and EvalAssist lets users choose the model they want to evaluate with, whether that's a small local model or a specialized judge. So for our off-the-shelf models, we use a chain of thought style workflow. The model first generates an open-ended assessment based on the criteria, then makes a final decision, and finally summarizes the reasoning for the user. We also check for positional bias by shuffling the order of the options. And so this is right here is the prompt for one of our llama models. This is the chain of thought prompt that varies across the other evaluators. We also support dedicated evaluator models, for example, Prometheus-style judges, which don't require chain of thought prompting to the same extent. So Prometheus is different from taking a general purpose LLM and prompting it in a chain of thought style to act as a judge. It's been trained directly on evaluation signals to score, compare, and articulate criteria. We wanted to offer both options to let users experiment and decide ultimately which is the most appropriate for their task. Our fifth goal is about transparency. EvalAssist flags positional bias during evaluation so users can understand when the judge model may be favoring one response over another simply because of the ordering. And our sixth design goal was to support flexible evaluation methods. I talked about direct assessment versus pairwise comparison earlier, and we really wanted to offer both approaches because direct assessment lets you evaluate outputs against a rubric, while pairwise comparison lets you compare responses against each other to choose the best one. And our seventh design goal was to provide structured templates. Not everyone wants to define evaluation criteria from scratch, especially for complex areas like harms, risks, or hallucination. So EvalAssist includes a catalog of customizable templates that give users a starting point. Specifically, we have an example catalog of harms and risks for our Granite Guardian models, which is one of the specialized models at IBM and is trained for safety and evaluation. And it consists of human annotations for harm categories like bias, profanity, sexual content, violence, and unethical behavior. And so we provide a suite of criteria for using Granite Guardian as an evaluator. For example, this is the jailbreak criteria that works well with the Granite Guardian model. Okay, so now we're going to see some examples of EvalAssist in action. We saw our design goals, so we can now see what the system looks like. So what we have here is the pairwise comparison interface. And the task that the user is creating criteria for is faithfulness. So they have some sample data. They have a task context. They're going through and selecting their expected outcome. It's a ranking because it's pairwise, and that's what's generated from the pairwise comparisons. Now the evaluation is being run. And they were able to achieve agreement in one go, which is impressive. Now, this is an example of direct assessment, and the task they are working on is around inclusivity. So they're filling out their criteria, and here you see the interface looks a bit different. They're filling out a rubric rather than just a statement that would determine which is better, like what we saw for pairwise. Their expected results are the labels they themselves have populated in their criteria. And we see them iterating a little bit here. And I just sort of fast forwarded for time purposes. But here they have positional bias was flagged, and they see the explanations, and they're reading about positional bias. So yeah, that's one of the direct assessment cases. Okay, so we also provide a suite of well-known benchmarks in the platform, which is open source. I should have mentioned that earlier. So users can see how different evaluators perform. This makes it easy to compare judge behavior across various tasks. And I mentioned the SDK before, but users can leverage the SDK once they've decided on criteria. They export their JSON criteria and then apply it to the entire data set. So next I'm going to talk about a controlled experiment we ran with users to better understand how people achieved alignment when running evaluations. Our study was focused on task-specific evaluation. So we examined how users define and refine criteria, how direct versus pairwise strategies impact evaluation effort, human AI alignment, perceptions of bias, and trust in the model. Broadly, we were asking, how do people evaluate, and how does the choice of strategy shape that process? So we ran a within subject study with 15 internal participants whose roles ranged from AI engineer to research scientists. All participants had evaluation as part of their workflows. And everyone completed 3 tasks twice, one under direct assessment and once under pairwise comparison with randomized ordering. Tasks spanned the Q&A context, summarization, and email generation. Some of the videos we saw before were from our study. So we were able to capture things like number of evaluations run, changes in the criteria, configurations during the evaluation process, and then also human AI agreement. After each task, at the end of each study, we collected behavioral measures like number of evaluations, alignment with the evaluator, and logged the changes during each evaluation. And at the end of each task, we asked participants to reflect on their preferred assessment methods. So we found that participants ran more evaluations under the direct assessment condition than under the pairwise. And this suggests a higher engagement and a greater sense of control. We also saw marginal differences in human AI agreement across tasks, with people achieving more agreement in the objective task, like the Q&A task, rather than the subjective tasks. We found that participants found explanations more helpful under the direct assessment condition. And we also found that participants experienced a higher cognitive load in the summarization task than the Q&A task. So we wanted to understand editing patterns that people were making in the criteria. And so we qualitatively analyzed it. So we saw that participants employed strategies like specificity. This is making the criteria more specific to the task content. They added rules to their criteria. They added exclusion criteria. So, do not penalize the summary for omitting unimportant details. And participants employed these strategies to ultimately reach the end goal to align themselves with the AI evaluator. So in addition to the edits made to the criteria, like making it more specific, more general, or adding options or minor edits, we logged other behaviors, including when people changed their own expected results or switched AI evaluators. And we found that the path to agreement or alignment between the human and the evaluator doesn't look the same for different users. So people took various paths to reach a point where they felt satisfied and there was agreement between themselves and the AI evaluator. For example, participant 10 in the email generation direct assessment condition continuously made their scale items more and more specific till they felt satisfied. Whereas here, participant 3 in the summarization pairwise example employed lots of different strategies, including changing the model and making the criteria more general. We even observed participants changing their own responses to align more closely with the models after seeing the model's explanation. So these were reactions like, well, maybe my interpretation of inclusivity is too strict and maybe the AI model is correct, which was a surprising sort of finding and seeing how people were changing their own responses to agree with the AI evaluator. We also asked participants which assessment method they preferred. The plurality preferred direct assessment, mainly because it gave them more clarity and control over outcomes and let them look closely at individual responses, which felt better for classification style tasks. About a quarter preferred pairwise, especially for more subjective or nuanced tasks where it's easier to compare responses than define a rubric up front. And the remaining group said neither or a combination, arguing that hybrid approaches actually work better, rubrics for defining standards and pairwise for resolving tricky preferences, and that the right method is task dependent. So one of the key sort of takeaways I want to leave you with after this talk is that evaluation is a collaborative process. Humans bring the context and the values, and models bring the scale, speed, and consistency. And across our study, the most reliable evaluation pipelines didn't come from replacing human judgment with AI, but pairing the two. Thank you so much for listening to me present this work. This was a work that was a collaboration with colleagues at IBM, and it's open source, so you can check it out. and I'm happy to take questions.